All right, so today is day 2 of set theory notes. Yesterday was pretty easy. This one is about subsets, proper subsets, equal sets, universal and empty sets. So the first little term we need to know, and symbol, is a subset. It's basically I wouldn't call it a C. It's more like a U on its side with an underline, and it's the symbol for subset. A is a subset of B if every element of A is also in B. So you write it like this. You'd say, okay, you would read that A is a subset of B. And for instance, if A was, right, A and B and C, and D and B was A, C, B, D, then A would in fact be a subset of B. Remember, they don't have to be in the same order. So if you're like every element of here can be traced to an element there, then you can say A is a subset of B. What's weird is it is allowed to be equal. I want you to think of this like think of it like a less than or equal symbol. It's sort of like a less than or equal symbol, even in looks, right? It's just not as sharp. This one's definitely smaller than this one because this has 3 elements, that has 4. But even if I took this out, that statement's still true. Is A a subset of B? Yeah, because every element of A is also in B. So you don't have to be bigger. So think of this like less than or equal to. So that's what subset is. It's a new symbol you learn. There you go. Now, similarly, if you do it without the line below, it's called a proper subset, right? And a proper subset, let me pause it and write. Okay, so the definition of proper subset, just like you would predict, since this one looks like a less than or equal to sign, and this one looks more like a less than sign. A proper subset, A is a proper subset of B if every element of A is also an element of B. Starts out the same as that one, but A is not equal to B. So this wouldn't fly for down here because those two are equal. Now they scratched out the D. So you'd write it like this. A is a proper subset of B. And let's do 4, 5, 6, right? So let's say that's A, and B is 1, 2, 3, 4, 5, 6. Okay, so A is a proper subset because you can find every element with its link here, but you wouldn't call them equal. Which brings us to our next one, right? So if we talked about subset and proper subset, we haven't talked about equal, right? Set A equals set B if A is a subset of B and B is a subset of A. Which means they have all the same elements. Reminder, order does not matter. So these ones up here, not only is a subset of B, but they're also A is equal to B. So anyway, I mean, you just write it like this. Capital letters for, and that's what you'll actually notice. I didn't say that before. Usually for a set, we use a capital letter, and for the elements, we use lowercase letters. I mean, unless you're doing a set of capital letters, then that's weird. All right, so 2 more things. We talked about, so now you know some symbols, but there's 2 special sets we need to talk about. One is the empty set. And the empty set, or null set, if you do computer programming, you see the term null, and it means this thing. It can be written, it is a set containing no elements. You've used the symbol before in math class when you meant to answer no real solutions. You would do this. That's the symbol for empty set. Or if you love drawing sets with the curly braces, which I know you do, you could actually draw a set that is empty with no elements in it. So that's what an empty set is. If you ever have, you can say null set too. Know both of these. If you ever have a set with no elements, you can write it like this, or you can write it with the 0 with a slash through it. That's a symbol for empty set. Because when you ever were giving the answers to a problem that had no answers, you were actually giving a set of no answers, which is this symbol. Kind of weird. One thing that's weird is if I wrote this kind of bends your mind a little. This is not an empty set. And I know, you're like, wait a second, but that's nothing. There's nothing in that one. But there is. Look, this is an empty set with nothing written in it. This is a set with one element. That element happens to be a set. So is it possible to have sets built of sets? And the answer is yes. Yes, it is. Okay, so let's try some of these out. Let me get some problems to try out. Oh, wait, hold on. We have our last thing, our last definition before our problems. The universal set. So if the empty set is a set containing no elements, a universal set is the set of all possible elements for each situation. It's symbolized by a bold U. So I usually do this. Just so you know it's bold. You kind of give it some extra sprouts because it's hard to write bold. If you were typing, you'll see it as bold. So that's what a universal set is. So if I were doing like, where's this? If I were doing this, I think a good universe for this would be the alphabet, right? A through Z. That would be all. And if you were doing these, maybe all positive integers, right? So universal set kind of changes depending on the problem. All right, one last vocab thing, and that is the complement. Okay, the complement, you've already done this in logic, of set A is written as A with this prime here. In logic, we would put the little not symbol in front of it. This doesn't mean take the derivative. This means, or it's not a derivative. It's just with a little slash, a little apostrophe up there. It means not. And it is the set of all elements in the universal that are not in set A. So basically it's everything that's not in A. If you see that, how do I pronounce it? I pronounce it A not. All right, let's do some problems now. Okay, let's crank through some questions here, true or false questions, to see if you understand the whole subset, proper subset, and equals thing. All right, so the first one, I read that, and I want you to be able to read these. All right, here's my collection of sets I'm using. A is a subset of B. Okay, that means every element of A shows up in B. And right here I find one that doesn't. So as soon as I find one that doesn't, I say that's false. Okay, how about B is a proper subset of D? That means it has to, not only is every element of B have to show up in D, but they can't be equal. So let's check. Does every element of B show up in D? There's a B there, there's a C there, but they're not equal, so that's true. Okay, how about this? B is a subset of A, meaning every element of B better show up in A. Okay, there's the B, there's the C, and they're not, oh, they're allowed to be equal, so I don't even care. I just care that this one has a B and a C in it. True. How about A is a subset of D? Does every element from A show up in D? There's an A, there's a B, there's a C, there's a D. So yes, every element is there. Are they equal? Meaning, does every element from this guy show up in here, and every element of this guy shows up in here, and order doesn't matter? That's true. They're the same. Is A a subset of C? Does every element of A show up in C? No, it's missing the A. I think it has everything else. There's the B, there's the C, there's the D. Yep, so if one of them's missing, it's false. Alright, so hopefully that makes sense. We'll do a different example with all the other cool stuff. Alright, so question A, I want to know what is A naught? Okay, so if my universe is 1, 2, 3, 4, 5, 6, and my set A is 2, 3, what is A naught? A naught should be everything that is not A. So you have to know your universe. If those two make A, then A naught is 1, 4, 5, 6. Okay. My second question would be, what is B naught? Okay, and B naught is everything that's not B. Here's 1, 4, 5, 6. So everything that's not B is 2, 3. So then if I asked a question like, well, actually, let's do what is C naught. Okay, if C is just 4, right? Everything that's not 4 is 1, 2, 3, 5, 6. Okay, then I could ask a question like, is C naught, so we'll go true or false. Is C naught a subset, let's do proper subset of B naught. Let's check them out. Here's C naught, 1, 2, 3, 4, 5. B naught, no, there's more elements here, and it has to be less than, so that's false. Okay, let's do one more here. What about, is A naught equal to B? Okay, A naught. A naught is everything that's not 2 or 3, so 1, 4, 5, 6. Is it equal to B? 1, 4, 5, 6, that's true. Okay, so just getting used to these things. They're not hard. Just get used to the symbols. What is not? What is universal? What is empty set? What is subset, proper subset? Oh, here's one. Let's say I had another one, D. That was 1, 2, 3, 5, 6. Okay, so what if I said, for my last question, what is D naught? D naught is everything in the universe that is not in D. 1, 2, 3, 4, 5, 6. They're all there. So what's D naught? You can write it two ways. You can write empty set, or you could do an empty set. I usually like this one because it's quicker and you don't have to write curly braces. So the opposite of a universe, the complement of a universe is the empty set. Kind of cool. All right, people. Hope that helps. Talk to you later.